In this video, we are going to talk about the metric system of measurement. Now, the metric system has one basic unit that kind of starts in the center, or our base unit. This can be a distance, a volume, a weight, and then we manipulate it in order to get all of the different units on that scale. So the nice thing about the metric system is that it's all in powers of 10, or factors of 10, as we go up and down the system. So for example, if my base unit is gram, then in the center here I have gram, which we can use G for gram, and then I can go up and down the metric system to get the rest. So if I go down, I get decigram, which is done with the prefix of a lowercase d, and then I have centigram, which uses a C, and milligram, which uses a lowercase m. And then as I go up, I can have decagram, which you can see this as a capital D, or you can also see it as DA. So either of those represents decagram, and then I have hectogram, which uses an H, and kilogram, which uses a K. And so by using the base unit, I can go up and down to get all of the other units. Now this keeps going, it doesn't stop at milli and kilo, it does keep going, and so in the medical field or other fields, we may use something called a micro, which is actually a few more down from the milligram, and we can use MCG, or this kind of funky UG, to represent micro. So every measurement in the metric system will have a base unit and then a prefix which tells you where it is on that scale. And so the simplest way to convert along this line is to see where your unit is and where you're trying to get to, and then kind of count the number of spots or jumps you need to get there. So for example, if I want to convert 45,200 meters to decimeters, we can look at our scale. So if I kind of draw a miniature version of our scale here, we have meters, and then if we go down, we have decimeters, centimeters, and so on. And so to get from meters to decimeters, I have to do one jump to the right, or in other words, I'm timesing by 10 one time. And so if I take my number, 45,200, I'm going to take my decimal point and I'm moving it one jump to the right. And so I end up with 452,000 decimeters. And so I'm timesing by 10 for each time I jump to the right, and then I would divide by 10 for each jump I jump to the left. So let's try this one. So I want to convert 2.834 hectogram to milligram. So if I again look at my scale, I'm using grams, which is right in the center. And if I go up, I have decagrams, and then hectograms, and if I go down, I get decigrams, centigrams, milligrams. So if I start at hectograms and I want to get to milligrams, that's 1, 2, 3, 4, 5 jumps to the right, or I'm going to times by 10 5 times. So if I take my number and I'm going to jump 5 times to the right, so I take the decimal point, 1, 2, 3, 4, 5, then that means my final answer is 283,400 milligrams. So kind of whatever we have to do in our scale, we're going to do that same thing to the decimal point in the number. So I've got 2 more up there for you to try. If you can pause the video, try them out, and then start it up again when you're ready. Okay, so let's convert 942 milliliters to decaliters. So let's look at our scale. We're working with liters, which is right here. And if I go down, I have deciliters, centiliters, milliliters. And if I go up, I have my decaliters, which again can look like this or like this. And then hectoliters, kiloliters, and so on. I'm trying to go from milliliters to deciliters. So I'm going to jump 1, 2, 3, 4 times to the left. So I take my number and I'm going to jump 4 times to the left. 1, 2, 3, 4. My decimal point is going to be right there, and we always stick a 0 in front of our decimal point. To get to our deciliters. And lastly, we have 0.045 grams to micrograms. So if we look at our scale, I have grams is our base unit, and if I go down, I have decagrams, centigrams, milligrams, and I have 2 more, and then my micrograms. So if I get from grams to micrograms, I'm going to do 1, 2, 3, 4, 5, 6 jumps to the right. So 1, 2, 3, 4, 5, 6 jumps to the right, and I get 45,000 micrograms. Okay, let's try some word problems. A low-strength chewable aspirin tablet contains 81 milligrams of aspirin per tablet. How many tablets may be prepared from 1 kilogram of aspirin? Okay, let's read that again. We have a chewable aspirin tablet that contains 81 milligrams is 1 tablet. And we have 1 kilogram of aspirin, and I want to know how many tablets can fit inside of that. Well, I have 81 milligrams in a tablet and 1 kilogram in total. So I need to make those units the same. So I'm going to take my kilogram and put that into milligrams to help me out. So if we look at our scale, we have grams in the center. We've got decagrams, hectograms, kilograms, decigrams, centigram, milligram. So if I want to go from kilogram to milligram, I'm going to do 1, 2, 3, 4, 5, 6 jumps. So we'll take our 1, and we're going to do 1, 2, 3, 4, 5, 6 jumps. To get to milligrams. So I have 1,000,000 milligrams and 81 milligrams per tablet. So now I'm going to take my milligrams and divide that by 81. And I get 12,345.679. And this would be tablets. Now, we can't prepare part of a tablet. A tablet is a solid, and so we need to prepare only whole numbers in tablets. And I can't make a tablet out of 0.679 ingredients. So even though regular rounding rules are telling me to round up, in this particular case, I can't make a whole nother tablet. I don't have quite enough to make another tablet, so I need to actually round down. So when we're doing word problems, we do have to think about the situation in order to know whether regular rounding rules would apply or not. And in this case, regular rounding rules are not going to apply because I don't have enough to make one whole another tablet. Okay, so how many colchicine tablets, each containing 600 micrograms, can be prepared from 30 grams of colchicine? Pause the video and then start it up again when you're ready. Okay, so again, we have a situation where we have 600 micrograms equals 1 tablet. And I have 30 grams in total. So again, we need to make our units the same here. So I'm going to convert grams into micrograms. So if we look at our scale, I have grams, decagrams, centigrams, milligrams, 1, 2, and then our micrograms. And so to go from grams to micrograms, I'm going to do 1, 2, 3, 4, 5, 6 jumps to the right. 1, 2, 3, 4, 5, 6. So I have 30 million micrograms of colchicine that I can use to make tablets. And so I'm going to divide that by 600 per tablet. And I get 50,000 tablets. An inhalation aerosol contains 225 milligrams of a medication, which is sufficient for 300 inhalations. How many micrograms are in each inhalation? So 225 milligrams equals 300 inhalations, and it wants to know how many micrograms are in each one. So let's first take our 225 and we're going to divide it by 300 to figure out how many milligrams are in each inhalation. And I get 0.75 milligrams. And we want to know what is that in micrograms. So if I look at my scale, I have milligrams and then 2 spots before my micrograms. And so I need to go 1, 2, 3 jumps to get there. So 1, 2, 3 jumps is 750 micrograms. We can also convert between area and volume units, but we have to do them just a little bit differently. So if we think of area, area happens because we're looking at a 2-dimensional shape. So I have a length, let's say, that goes this way and this way. So if this square was 1 meter squared, and I want to know how much is that in centimeters squared. Well, a lot of times we would say, well, 1 meter to get to centimeters, there's 100 centimeters in a meter, so therefore it's 100 centimeters squared. Well, let's take a look at that. If I divide this length into 100 chunks, then I have 100 of these rectangle pieces, which isn't a square, which means that each of these is 1 centimeter by 1 meter. So that's not 100 centimeters squared. I also have to divide this way by 100 in order to get those squares. And so I don't end up with 100 of those pieces. I end up with 100 of 100. And so because we're doing area, I have to convert the length and I have to convert the width in order to find the actual conversion. And so with area, we have to do it 2 times, right? 1 for the length and 1 for the width. With volume, the same sort of strategy applies in the sense that I'm going to have to convert the length, the width, and the height in order to get the actual conversion. And so with volume, I have to do it 3 times. So the area, there's 2 dimensions. That's why we say our units are squared, or to the power of 2. And so I have to do it 2 times. With volume, we get a cubed, right? It's to the power of 3. And so I need to do it 3 times in order to get the correct one. So it's not just once. I don't just do the conversion once, I do it twice. And with volume, I do it 3 times. So what do I mean by that? Well, if we look at our first example here, we have 0.0005 kilometers squared to decameters squared. So if I look at my scale, I have meters down here. Then I have decameters, hectometers, and kilometers. So if I want to get from kilometers to decameters, I'm going to do 1, 2 jumps, right? But because it's an area, I'm going to do that twice. And so I'm actually going to do 4 jumps, 1 for each dimension. And so I take my number, and I'm going to do 2 jumps, and then another 2 jumps to get 4 jumps altogether. So I end up with 5 decameters squared. Okay, so whatever I would normally do, I'm going to do double because I have 2 dimensions to worry about. Okay, so I want you to try question 2. Pause the video and then start it up again when you're ready. Okay, so if we look at our scale, we have meters, decameters, hectometers, kilometers. And so if I go from meters to hectometers, I have to do 2 jumps to the left and I'm going to times that by 2 because it's an area. And so I'm going to do 4 jumps to the left. So if we take our number, I'm going to do 4 jumps, 1, 2, 3, 4. And I get 0.0034 hectometers squared. For volume, same strategy, except now I have 3 dimensions, so I'm going to triple what I would normally do. So if we look at the units we have here, we have hectometers and then kilometers. And so if I want to go from hectometers to kilometers, it's 1 jump to the left, and I'm going to times that by 3. So I'm going to do 3 jumps to the left. 1, 2, 3, and I get 4.2 kilometers cubed. Okay, next we have some conversions that go between a meter or a length measurement to a volume measurement in terms of liters. And so the conversion that kind of bridges that is 1 decimeter cubed equals 1 liter. So 1 decimeter cubed equals 1 liter. And so when we have more than one step with the conversion, we want to try and find a pathway to get us there. So in this case, I need to go from cubic meters to centiliters. And my bridge is this decimeters to liters. So I'm going to need to go from meters to decimeters, then to liters, then to centiliters. So it's like a 3-part question here. So if I'm looking at my meters to decimeters conversion, we know that we have meters as our base, and then we have decimeters, centimeters, millimeters, and so on. And so to go from meters to decimeter, I need to do one jump to the left, but I'm going to times that by 3 because it's a volume. I have cubic. It's not meters to decimeters, it's cubic meters to cubic decimeters. And so I'm first going to take my number here, and I'm going to do 3 jumps, 1, 2, 3, to get 0.5 decimeters cubed. And we know that 1 decimeter cubed equals 1 liter. So that means this is also going to be 0.5 liters, right? They're a 1-to-1 ratio, so 0.5 decimeters cubed is 0.5 liters. So now I need to go from liters to centiliters. So it goes liters, deciliters, then centiliters. So I'm going to do 2 jumps to the right to go from liters to centiliters. Now, do I need to double or triple this? No, because they're single units. They're one dimension. It's liters to centiliters. It's not cubic liters or square liters. It's just liters to centimeters. And so I only need to do the original conversion of 2 jumps. So altogether, I get 50 centiliters. Okay. So I want you to try question number 5. You're going from milliliters to cubic centimeters. So a couple tips with this: find your pathway. So the first thing you want to do is plan out your route. How are you getting there? And then just take it one step at a time. Remember that you are only doubling or tripling what you're doing if there's a square or a cube on both of the measurements. Okay, so let's take a look. I need to get from milliliters to cubic centimeters. I know my kind of middle bridge is 1 decimeter cubed is 1 liter. So I first need to get to liters, and then I can get to decimeters, and then I can get to centimeters. So I'm going milliliters to liters, then to my decimeters cubed, and then to my centimeters cubed. So to get from milliliters to liters, I've got deciliters, centiliters in between. So I'm going to do 1, 2, 3 jumps to the left. So if I take my number here, 4, 5, I'm going to do 3 jumps to the left. And so I get 0.00245 liters. Okay. Now we know there's a 1-to-1 ratio there. So that means this is also 0.00245 decimeters cubed. So if I want to go from decimeters, if I have meters, decimeters, centimeters, millimeters. So to go from decimeters to centimeters, I'm going to do 1 jump to the right, but my actual conversion isn't decimeters to centimeters, it's decimeters cubed to centimeters cubed. So I'm going to times that by 3. I'm going to do 3 jumps to the right, and I end up with 2.45 centimeters cubed. Okay, so you're going to rate yourself on here a thumbs down if you're having trouble using the metric system to do conversions, including our area and volume units. You're going to do the finger pointed if you need more practice, and a thumbs up if you're like, I've got this, I don't need any more help or practice, I understand.